Here I want to look at a problem that might cover a couple topics that could show up in Event C during Meet 5. The problem has 150 people in total, can drink any of 3 brands of soda. There's 58 people who drink brand A, 49 people drink brand B, 57 people drink brand C. Then 14 drink A and C, 13 prefer A and B, and 17 prefer B and C. And there's 4 people that don't matter at all, A, B, and C. The question is, how many people drink no soda at all? I'm going to go through 2 methods for solving this problem. The first one involves a Venn diagram. Of course, with a Venn diagram, we notice we have the 3 interlocking circles inside of this big rectangle. Each of those circles will represent a different brand soda. So I'll let this circle represent brand A, this one be brand B, and on the bottom here, brand C. So every region where the circles will overlap, then that would be talking about the situation where we have A and B, or A and C, or whatever. That also means that outside of the circle, the rest of the box is for everybody that drinks no soda at all. Now, as you're filling in a Venn diagram, it's important to work from the middle out. In this case, what I'm talking about is first we'll look at this region in the very center that's talking about all the people that drink brands A, B, and C. And we know that that altogether is 4. Then we're going to kind of work our way out from the middle. We've already talked about the intersection of A, B, and C. Now we'll go to these 3 intersections. On the Venn diagram, the intersection of A and C is this region right here. And it says that we have 14 people that drink A and C. Well, 4 of those people are people that drink A and C and also B, which means there are 10 people left over that are only going to drink A and C, but not B. For those that drink A and B, we're talking about this region here. It says that there are 13 people that drink A and B. 4 of them have already been accounted for, making 9 left over. And then finally for B and C, that would be this region here. It says that there are 17 people drinking B and C. 4 of them, of course, have already been accounted for, meaning there are 13 left over that solely drink B and C without A. Now that all 3 of these are finished, we move on to the next ring, and those are the people that will only drink A or B or C. For all the people that drink A, we're talking about this circle here. It says that there's a total of 58 people that drink A, but we've already got 23 people accounted for by those that are drinking A and B, A and C, and A, B, and C. So when we start with the 58 total people and subtract the 23 that are already accounted for, we're left with 35. And we go through this similar process with B and C. When we're talking about B, there's a total of 49 people. 26 have already been accounted for, meaning that there's 23 left over. Lastly, there's 57 people that are drinking C. This circle represents all the people that drink C. 27 of those people have already been accounted for, meaning that there are 30 people that will only drink C and nothing else. Now that we have all of the circles filled in, we can pretty much answer our question. We can see where we're at. We have all the people who drink soda are accounted for. They're filled in all the spots. Adding up all the numbers that are in the circle, there's a total of 124 people that are drinking soda. So if we started with the 150 people all together and subtract the 124 people that drink soda, that leaves 26 out here that's not in any of the circles that won't drink any soda at all. The second way I want to show you how to solve this problem is using an idea from discrete math called the principle of inclusion and exclusion. And what this does is allow us to just kind of look at the numbers and add or subtract them to to find out how many are left over. Now, what we're looking for is, first of all, to find out how many people drink A or B or C. Notationally, we would say A union B union C, and these absolute values just say, that's the cardinality of the set. So how many cardinalities, how many numbers are going to be in the set of A or B or C. And to start off, you start by just adding together how many people are in A and how many people are in B and how many people are in C. However, what we saw is, of course, that includes everybody that drinks A. And that includes the people that drink A and B and A and C and that drink all three of them. So there's a couple of these groups that got counted more than once. So now we go through and subtract off all of the A and B's and the A and C's and the B and C's. Of course, now we've subtracted off too many because that little piece that was in the middle got subtracted off too many times. So we have to go ahead and add that back in. So we have to add back how many people are in A and B and C. And this is what the principle of inclusion is. So for this particular situation, our union of A, B, and C, we're going to start off with all of each set individually, the 58 and the 49 and the 57. Then we're going to go through and subtract all the double intersections, the 14 and the 13 and the 17, and finish up by adding back in that triple intersection, the 4. Doing so, we'll end up with 164 minus 44 plus 4, which is 124. Of course, this is all the people that drink A or B or C in any sort of combination. The question asks us, of course, how many people don't drink any soda at all. So, not the number of people that would drink no soda, we would start with the 150 and subtract all the 124 people that drink at least one kind of soda, and again we're left with that 26.